In this example, we want to graph a quadratic function in standard form. This is sometimes also called vertex form or graphing form. So given our function, we want to find the vertex, the equation of the axis of symmetry, the y-intercept, and then graph the function. So for a quick review, if a quadratic function is in standard form, if a is positive, the parabola will open up. If a is negative, the parabola will open down. The vertex of the parabola will have coordinates hk, but we do need to be careful about the sign here. Notice how it says minus h, and the x-coordinate of the vertex is h, and it says plus k, and the y-coordinate of the vertex is k. And then if hk is the vertex, the equation of the axis of symmetry would be x equals h. So looking at our function, the first thing we should notice is that a is equal to negative 2, so this parabola is going to open down. Next, for the vertex, since we have x plus 1 here, the x-coordinate is going to be negative 1, and because we have plus 4 on the end here, the y-coordinate will be positive 4. And then because the x-coordinate of the vertex is negative 1, the equation of the axis will be x equals negative 1. And then to find the y-intercept, we have to set x equal to 0 and solve for y. Remember, y is equal to f of x. We would have y equals negative 2 times the quantity 0 plus 1 squared plus 4. So 1 squared is 1 times negative 2 is negative 2 plus 4 equals positive 2. Remember, the y-intercept is a point, so the x-coordinate would be 0 and the y-coordinate would be positive 2. Now let's graph the parabola. Let's start by sketching the axis of symmetry or line of symmetry. It's x equals negative 1, which is a vertical line passing through negative 1 on the x-axis here. Next, the vertex has coordinates negative 1, 4, which will be on the axis. Negative 1, 4 would be right here. Next, we'll plot the y-intercept, which has coordinates 0, 2, should be this point here. Now, because we have the axis of symmetry, we know there's going to be another point on the other side of the axis, which would be right here. So this may be enough information to sketch the parabola, but let's go ahead and find two additional points. Let's determine the function value, let's say, when x is 1. To do this, we'll evaluate f of 1, which would be negative 2 times the quantity 1 plus 1 squared, or 2 squared, plus 4. Well, this is going to be 4 times negative 2, that's negative 8, plus 4 is negative 4. So if f of 1 equals negative 4, that means the parabola will contain the point with an x-coordinate of 1 and a y-coordinate of negative 4. So let's go ahead and plot that point as well. 1, negative 4 would be here. And then as long as we have the axis of symmetry sketched, we can actually plot 2 points for every point that we find. If this point is 2 units to the right of the axis of symmetry, there must be another point 2 units to the left, or this point here. And now this is more than enough information to sketch a nice graph of the given parabola. It would look something like this. And of course, to verify this, we could graph this using software, which I've done here just to verify our answer. Now the scale is a little bit different on this coordinate plane, but the graph is the same as the graph we had on the previous screen. We'll take a look at another example in the next video. I hope you found this helpful.